Greetings, glad to be joining you for 2022 SUSECON. My name is Philippe. I'm Director of Open Source Infrastructure at Arm. I've been with Arm for over 20 years, developing the open source and software partner ecosystem to enable Arm. For this presentation, I will be discussing Arm Neoverse and the work we've been doing with SUSE and the partner ecosystem on Arm to enable support for cloud and edge platforms. Starting with a few words about Arm. Arm is the leading semiconductor intellectual property supplier with over 500 silicon partners. Our partners license and combine Arm intellectual property with their own IP to create complete chip designs. Our technology securely powers products from the smallest sensor to most of the world's smartphones and even the world's most powerful supercomputer. Arm's focus has been on design of energy-efficient processors. Since 1990, our partners have shipped over 225 billion chips. The pace of shipments is accelerating, and last year alone, over 29 billion chips shipped with Arm-enabled technology. Together with our partner ecosystem, we are at the forefront of designing, securing, and managing all areas of connected compute, from chip to the cloud. The infrastructure is evolving. IoT and the edge increasingly play a crucial role in supporting a diverse use cases, with a varying range of power and performance requirements. In the past, traditional IoT deployment models have been to generate data through sensors and endpoints in large volume at the edge, where cost and power consumption is key. Getting insight and acting on this data then took place in the cloud, where all the smarts are with almost unlimited resource in power, compute power, and storage capacity. As we scale to 1 trillion devices, that model is no longer sustainable, mainly due to the sheer amount of data being generated and needed to be moved with an infrastructure that is unable to scale as fast. To deliver sustainable services at scale, the IoT embraced cloud-native software principles to consistently and securely enabling distributed compute models from the cloud to endpoints. Scalability and fragmentations are critical to enable the migration of workloads from the cloud closer to the data at the edge, while creating a consistent, more homogeneous deployment model for end applications. To support this, Arm announced an industry-wide initiative in 2019 called Project Cassini that addresses this to better support IoT deployments. This evolution of IoT requires a deployment model that makes it simpler to scale, where things just work in a more standardized way. Arm first announced its Neoverse platform in 2018, and since then we've seen a wave of adoption throughout cloud to edge infrastructure, with a rich diversity of hardware and software solutions that have come to market and are now deployed in cloud data centers, HPC systems, 5G networks, and extend to edge gateways. To give a few examples, we are now seeing cloud service providers like Amazon, Microsoft, Oracle, and Alibaba adopting Arm and offering compute instances that are both high-performing and offer cost advantages. Arm Neoverse platform is delivering significant performance gains. In HPC, for example, the Fugaku supercomputer was awarded top supercomputer in the world for the past 3 years. Arm is the preferred architecture for OEMs and telecom operators, with the likes of Nokia and Samsung in 5G RAN space. Our standards and certification programs continue to grow and expand to the infrastructure and IoT edge. With the launch of initiatives like Project Cassini and System Ready, we aim to have a variety of solutions that support standard operating systems and cloud-native software right out of the box. Cloud platforms are embracing Arm servers. Whether through AWS or Oracle Cloud Infrastructure, you can now take advantage of ARM-based compute instances and start running workloads on ARM in the cloud. There are cloud service providers who are embracing ARM servers through one of our ARM Silicon partners, Ampere Computing. And you have Ampere Ultra processors, which uses Arm Neoverse cores and was designed specifically for cloud and data center workloads. Ampere has announced several Tier 1 cloud service providers who have deployed servers or plan to deploy very soon. Among these, you have ByteDance, who is better known for the TikTok social video applications they created. Microsoft, who has used ARM processors in some of their internal services. And Cloudflare, who is a leader in CDN space with a worldwide network of content delivery infrastructure and security services. Several OEMs and ODMs like Foxconn, Inspur, Gigabyte, and Huawei have also announced servers SKUs around Ampere Ultra processors. And we are seeing a growing share of Arm Neoverse N1-based Graviton 2. Amazon was an early adopter of Arm in the cloud by designing their own server CPU using Arm technology. Their second-generation processor called Graviton 2 delivers 64 Arm Neoverse N1 cores on 7-nanometer manufacturing process. AWS now has several EC2 compute instances running Graviton 2. And most recently, AWS launched new extra high memory configurations. In some cases, we are seeing over 80% better throughput on these compared to all the X1 models. We were excited by the performance benefits such that Arm is now shifting more EDA workflow to Graviton 2. We are happy with the overall performance and the total cost of ownership benefits we have achieved through this. AWS Graviton 2 based instances offer up to 40% price performance gains compared to some alternatives, x86 M5 instances. And customers are seeing significant double-digit cost saving using those. According to Lifter Insights, almost half of the new instances added in 2020 were ARM-based Graviton 2 instances. In these slides, I wanted to just highlight some of the cloud workload performance we've observed running on AWS Graviton. Looking, for example, at web and search workloads, applications like Nginx achieved 57% performance improvements. Similarly, on databases using Redis, Memcached, or MongoDB, or Cassandra, we see very significant performance gains compared to other platforms. Video encoding platforms, we've achieved very good frame per second price performance benefits, improving 36% with H.264, H.265, for example. And EDA, as I mentioned earlier, with partner platforms like Cadence or Mentor, we've seen a significant cost reduction running on AWS Graviton 2. Arm has been working with SUSE for over 10 years now to help support the Arm architecture and platforms. This was through direct engagement with the upstream community as well as the OpenSUSE community. We've been working with partners to contribute support for the latest technology and platforms. We've built on SUSE workflow, including OBS and OpenQA. And popular Arm platforms like Raspberry Pis have also contributed to enabling Linux support on Arm. And it was great to see SUSE being the first to offer commercial support for SLES on Raspberry Pi. SUSE has multiple solutions available on Arm, including SUSE Enterprise Linux Server, version 5, SLE Micro, and there are also some AMI instances available on Amazon EC2 for people to use and deploy. Arm has also been working with Rancher prior to Rancher becoming part of the SUSE family, and we demonstrated K3S solutions on Arm as lightweight Kubernetes solution for edge platforms, and showing it was actually very well suited. On this slide, we look at a use case using K3S for some AI ML scenario of object detection. In this example, we use an NVIDIA Jetson Nano, which is a cost-effective device that can run GPU-enabled workloads and handle AI ML data processing jobs. These are cost-effective devices that can be quickly deployed and still provide an efficient way of performing video analytics and AI. Cloud-native technologies like Kubernetes have enabled developers to build lightweight applications using containers for the edge. K3S has been a key orchestration platform for compact footprint edge devices, enabling running of AI and analytics at the edge without putting strain on device RAM and CPU. In this example, we show a combination of NVIDIA Jetson Nano and K3S, enabling GPUs at the edge. This makes a compelling platform, and the figure on the right depicts a high-level architecture of this use case. In this setup, we have two video streams that are being passed as input to the NVIDIA DeepStream containers, a live video feed from the camera angled towards the parking lot, and a second video feed, which is a pre-built video with different types of objects like cars, bicycles, and humans. We also have a K3S cluster deployed on Jetson Nano that hosts an NVIDIA DeepStream. When the video streams are passed to the DeepStream pods, the analytics are done on the device itself. The output is then passed onto the display attached to the Jetson Nano. On this slide, we wanted to look at different use case, which is a self-storage cluster. This is part of a Hammerhead project, which is a collaboration between Ampere Computing, SUSE, Mellanox, Broadcom, and using the Ampere Ultra platform. We show the power performance advantage over an x86 cluster, particularly Tiger Shark, which is the name of the x86 cluster here, based on Skylake. This also provides a proof point that we can build efficient world-class storage cluster with ARM platforms. On the bottom left, we outline the configuration of the system that was being tested on using real-world configurations. And on the top right, we have a link to the blog and where you can find a more detailed explanation of the workload. The Hammerhead collaboration has continued, and there is a separate talk during this conference, during SUSECON, showcasing video on demand using the Hammerhead cluster. Our colleagues from Ampere Computing and SUSE will be presenting this, and I will provide pointer at the end of this presentation. Looking at 5G and the telecom space, this slide outlines some of the key performance efficiency that can be achieved into that space. To have an apple-to-apple comparison, we ran a commercial centralized unit and a distributed unit software stack for a microcell configuration. We did this on a traditional server as well as an ARM server. With the performance levels pegged as the target, we measured the core utilization and the power it takes to run the 5G network stack. As you can see, there is significant difference in the power level observed. Also with ARM server, since we're able to integrate a lot more CPU cores in a given power envelope, only a fraction of the server chip is utilized relative to traditional servers. This has direct implication on the total cost of ownership and the platform flexibility. This level of efficiency and the heterogeneity of ARM SoC portfolio is why ARM is gaining traction into the wireless infrastructure today. To facilitate the development of on ARM and access to platform, we launched the Works on ARM programs a few years ago. And this provides a good choice of platforms available to developers to develop on ARM. This slide lists some of the options available, ranging from Amazon Web Services, Equinix, Oracle Cloud Infrastructure, the open source lab hosted by Ampere Computing, and mini-nodes, which includes a range of edge platforms from Raspberry Pis to NVIDIA platforms. We also included some links and resource people can check for developing on ARM, including GitHub, some manual and tools, and other useful information. To reduce fragmentation and better support developers, we introduced Project Cassini a few years ago. Project Cassini regroups several initiatives. First one is System Ready, which is a compliance and certification program based on a set of hardware and firmware standards. In particular, the base system architecture, BSA, the base boot requirement specification, and a selection of supplements. We have multiple bands into this System Ready program. System Ready SR, which provides solutions for server or workstations. System Ready ES, which provides solutions for embedded devices and SmartNICs. System Ready IR, which is tailored to meet the needs of embedded Linux ecosystem on system based on ARM SoCs. And System Ready LS, which is more tailored to meet the needs of hyperscalers on system based on server ARM SOCs and targets hyperscalers Linux environment. On the right-hand side, we mentioned Parsec, which is a platform abstraction for security, which is an open source initiative to provide a common API to hardware security and cryptographic services on a platform agnostic way. This abstraction layer keeps workloads decoupled from the physical platform details, enabling cloud-native delivery flows within the data center and at the edge. We contributed the Parsec project to the CNCF, and it is now a sandbox project. And we have the PSA certified program, which offers a framework for securing connected devices, from analysis through to security assessment and certification. This framework provides a standardized resource to help resolve the growing fragmentation of IoT requirements and ensures security is no longer a barrier to product development. The PSA certified program is a global partnership program. And Project Cassini has been very, very successful with a broad adoption by leading silicon and device manufacturers across the IoT and infrastructure edge value chain. In fact, the participation has more than doubled from 30 partners 12 months ago to over 70 partners today. We have over 28 system-ready certified devices across various categories, including ARM silicon from partners like Ampere Computing, Broadcom, Marvell, NXP, and Rockchip, and more than 10 leading original device manufacturers. We have over 80 PSA certified devices today, and there is good traction for the Parsec project with integration into OpenSUSE, which we demonstrated last year at SUSECON, and Yocto Linux. We have new reference implementations delivered in partnership with NVIDIA and Rancher, Redis Labs, and so on. Last year, we announced and created ARM 5G Solution Lab to foster collaboration and innovation in 5G space. We've been partnering with leading telco system integrator Tech Mahindra to host the lab. Tech Mahindra brings a wealth of expertise in that segment with a broad operator relationship and a proven track record of running industry certified labs. The lab is to provide all of the key building blocks, secure remote access to state-of-the-art equipment, end-to-end components from UEs to radios, ARM ecosystem hardware, software, etc. All this to lower the barrier to work together on ARM platforms. In the automotive space, ARM launched SOFI initiatives last year, which SUSE is taking part to as well. SOFI is an industry initiative to extend cloud-native to automotive workloads. We have launched a special interest group to support discussions with partners, and it's an open group. People can come and join. And in the automotive space, we also have additional requirements such as functional safety and real-time platform needs to support. All of these are validated through an open source reference platform to help developers prototype and start development early into the cycle. And Project Cassini and System Ready are key enablers to these activities. You can find more looking at the link on the right on the sophie.io website. Arm is a Cloud Native Foundation Platinum member to support cloud native software development on Arm. And we've been engaging with the CNCF ecosystem and projects for quite a long time. We have over hundreds of open source projects building natively on Arm. We also work actively with developers and maintainers to optimize their software on Arm platforms. We have a large number of independent software vendors offering commercial support on Arm, and these are companies like SUSE that can help customers deploy and maintain solutions in the field. We have for many years worked with Docker to include pre-built images on Arm, so that developers can just start with developing their applications without having to rebuild components they need. CI/CD has now become an integral part of the development cycle, and we have over 1 million build minutes per month which are done on Arm infrastructure. Arm and partners are also doing a lot of optimizations to ensure software uses the latest features available with the newer Arm processors, and we actively and continuously work with SUSE to maximize performance and integrate the latest features. We've been collaborating to deploy solutions on Arm-based compute instances in the cloud and in the data center, and also to support the adoption of a robust and expanding hardware and software ecosystem. You can find more information on the Arm pages on the partner section in the SUSE website, as well as the infrastructure on the Arm website. And you can join us at the Arm Developer Summit, which is in the fall in October, where we have a combination of software developers and companies presenting the latest activity on Arm platforms. And go and visit those resources and websites to learn more and get involved. And finally, I mentioned the other partner session, which is available at SUSECON this month, which is a video on demand consumption for workloads on Kubernetes edge devices, presented by Brian Gartner from SUSE and Jeffrey Tu from Ampere Computing, just showcasing another workload onto the Hammerhead cluster that I mentioned on Ampere platform. Thanks very much for your attention, and looking forward to interacting with you during SUSECON and also for the rest of the years on the SUSE channel or the Arm channels. Thank you very much.